Hi, Ms. Boykin here. We're going to talk about solving inequalities. It's a topic that you guys have learned about in Algebra 1, but this is a quick review for you. Let's first take a look by, sorry about that. Let's take a look at both sides of our equation and see if we can do anything to simplify it. I see on the right-hand side I have a negative 2m and a negative m. That makes a negative 3m. And we just leave the negative 14 as is. Now we want to start moving our terms such that we have our variable term, negative 3m, over on the left-hand side. It'll work out easier for in the long run for that when we write our final inequality statement. So the opposite of negative 3m is positive 3m, and what I do to one side I'm going to do to the other. Okay, when working the problem, and 3m and negative 14, they're not like terms, so we just write those down. And now we can move the negative 14 over to the right-hand side. So we do the opposite by adding 14. We then have 3m is greater than or equal to 18. My last step is to isolate the variable. So 3 and m are being multiplied. The opposite is to divide, and divide by what we're trying to get rid of. So the 3 divided by 3 is 1, leaving me with m is greater than or equal to 6. And that's the solution to our first problem. Any value that's greater than or equal to 6, when substituted in place of m in both cases here, and worked out, will produce a true statement when you check it. Let's take a look at the next problem. This is problem number 3 on your homework sheet. A little more involved this time. We have a negative 3 outside of our parentheses. We're going to distribute that to both terms. So it's a negative 3 minus 18x is greater than or equal to negative 29 plus 8x. Just like before, we want to isolate the variable term and move it to the left-hand side. So let's move that 8x. Opposite is subtract 8x. We bring down the negative 3. Combining these two is a negative 26x is greater than or equal to negative 29, and this cancels out as it equals 0. My next step, once I have the variable term on the left, is to move my integer. Opposite of negative 3 is positive 3. And we're going to combine now. That equals 0. Don't forget, this is a negative 26. Don't forget to bring that negative sign down. And my last step is to isolate the variable by getting rid of what's being multiplied, and the opposite of multiplying is to divide. And we're dividing both sides. Canceling out, we get a positive x and a positive 1. Now before I write the sign in there, let me remind you of one more rule, which is if we multiply or divide by a negative number, we need to remember to flip the sign, flip the direction of the sign. And that's only when we are multiplying or dividing by a negative number. So the sign gets flipped, and there we have our answer. The other thing that I wanted to mention to you is if we happen to graph our inequalities on a number line, let me remind you of that rule. I'm going to erase this so I can have more room. When we graph inequalities, if we have a greater than sign or equal to, or less than sign or equal to, when we plot those, we're going to plot with a closed circle. Whenever we have a greater than or less than, it's not equal to that value, so we represent that by plotting with an open circle. You might remember that from Algebra 1. So let's go ahead and plot this. We have positive 1, and because it's equal to or less than, I'm plotting with a filled in circle, Now I'm shading the direction to represent anything less than that. Less than that would be shading to the left. And now we have our solution as well as our graph for problem number 3. Let's go to our next one. This time we're going to talk about compound inequalities. And what compound inequalities is, it's like two problems wrapped up into one. So I'm just going to write this a little bigger so I have a little easier time writing. Okay, so notice it's like there's a left side, there's a right side, and there's a center. So we're going to focus on the center. We want to isolate the variable b. So let's start out by removing the 3. What we do to one side, not only do to the left, but don't forget it gets done to the right. So we're working on all 3 sections simultaneously. 11 minus 3 is 8. This equals 0. Don't forget this is a negative 2b coming down. And 17 minus 3 is 14. For my last step, I want to isolate the variable b. It's being multiplied by the negative 2. The opposite is to divide. And I hope you're thinking that we are dividing by a negative number, so we have to flip our sign. So this is the direction of our sign now. When I rewrite it, it gets flipped because I've divided by a negative number. So negative 2 divided by negative 2 is a positive 1 times b is b. 8 divided by negative 2 is a negative 4. 14 divided by 2 is a negative 7. Now, whenever we're in math, you know how we like to list things from the smallest number to the largest, and this is not in that order. So I'm going to go ahead and switch this around. I'm going to list my smaller number on the left, my larger number, which is negative 4, because it's closer to 0, it's farther to the right on the scale. I'm going to put b in the middle. Now here we have b is greater than or equal to negative 7. The open end is at the b. So I'm going to put it that way. I'm just flipping it around. Here, the smaller point is towards the b. So when we rewrite these, we typically want it written in less than fashion, less than or equal to, and now we have it properly listed. So then when it comes time to draw our number line, it's going to graph exactly how it looks now, with the negative 7 on one side, my negative 4, that's closer to 0 on the right, and we have negative 5 and negative 6. Again, or equal to, so we're going to be graphing these with closed circles. At my negative 7, I probably should pick a different color, because if I color in blue over on here, you're not going to see it. There we go. And any values in between those two, or including those. So I'm going to draw my little barbell symbol, looking symbol, and there we go. Here is my solution, here is my graph, and once again, if you test it, you can pick any number, including either of those numbers, put it in to the original problem, and you'll get a true statement. So there you have it. If at any point, if I lost you, feel free to rewind my video. You can play it over again as many times as you want. And of course, if you have any questions and you're still stuck, please come in CAB Morning to see me. Be glad to help you. Talk to you guys later. Bye.